Hi, welcome back to our next session and our next speaker. Next up is Igor, and he will tell us about the TX Group data universe. Let's see if that relates at all to the metaverse we are in today. And yeah, let's also hope that Igor is not drunk, because one of his favorite things is to drink some beers with friends. And let's hope the nervousness for the talk didn't get him started early. Okay, handing over to you, Igor.
Thank you, Laura. Yeah, I have water with me, so it's not a beer, as Laura said. But all right, I am going now to present you and try to explain you some things what we in a TDA group of are working on, and we'll try in this quite a short time to tell you as much as I can to give you introduction what we are doing and what are the challenges. So I hope you all can see my screen. So title of my presentation today is TX Data Universe, with focus on something which is very I would say known inside of the company, which is called the data platform that our group is developing. So agenda of the talk will be something that I will start to tell you shortly about TDA. What is TDA as a group, what we are working on, and how. Then I will give you a short introduction about TX Data Platform to explain you what is it and what is the goal of this platform. Then we will tell you about technical challenge that we had during development of it. So I would say that's most of these things that I'm presenting you here is already done in production, so you already use it. You all have you all probably use some of our products of TX Group, so you can see them, and we'll explain you what were our technical solutions for it, how we actually were coming to some decisions, and how we build it. If we have some time at the end, we should get some more questions. So TX Group in generally TDA actually means TX Group Data Analytics. So we are a group of I would say nice people, not big group, but I would say pretty enthusiastic and experienced group of people who are working with a lot of data, and we are trying to combine a lot of data that are existing inside of TX Group. As you know, TX Group is actually contains quite huge number of web portals, platforms, or we are doing our business in different areas like marketplaces or news and so on. And all of these companies are owned by actually TX Group. I don't know exactly how much of them. I have here put short video of one of our monitoring tools that can tell you can see a list of portals and websites which are under our control, and that's quite a lot of data that we had to deal with and to work on. So I would say it's more than 20 of those portals and websites. And yeah, they are all owned by the company. So I would say owners of the company, they all like them because that's their business, and that's why this herd is here. But there is one big but in terms of engineering and the data. And that but is actually all of those companies are in some way kind of independent. They have their own development teams and different engineers and different technologies and different data structures, and quite everything is different. And company wants to look them as a part, same way. They share data between, combine data, and be able to get as much as possible knowledge from data that we have inside of company, and to be able to to build better products, to improve our products, to be more competitive on the market, and so on. Good thing for TX Group is that we are really owners of those portals and that people are using mostly in Switzerland. And at some way it gives some advantage. So the point is now how we can all of these things make running together and have all this data connected and bring more values to the business, so they can bring business decisions and easier some easier way, and then make us more competitive on the market. And this is actually where TX Data Platform comes in. So TX Data Platform is actually a set of applications or a set of tools and technologies that needs actually to do it exactly what I've shown on the previous slide, like to show you how we should combine this data and treat them the same way, so they can be shared between all of those companies. That means, like, if I'm in Ricardo, I want maybe to know what that user was searching on Tutti, or what is the interest of that user looking what he was reading on Tagesanzeiger or some other site. So I can build some recommenders or propose better ads and so on to that user. So that's actually goal of TX Data Platform, and that's what TX Data Platform is working, is doing. So I'm starting here with talking about already now challenge. So first thing was like how to make this data platform communicate and talk to all of these different portals, different sites, and different technologies, different engineering teams. So it was first goal was, okay, let's make data platform possible to get the data somehow from all of these sources, I would say, and because we treat them as a source of data. But that's not the point. The point is how it can be bidirectional. So how now we can enrich those data, make them more valuable, and give them back to those companies, and so they can build their products. So you can see I put a couple of screens here that products already in production, that you already can see them in some of our portals, like some recommenders, geo tools for target marketing, recommenders for videos, full data archive. Even there is a nice product, Farcaster, now built on top of data platform. So this, what I'm telling you and talking here, is something which is running inside of TX, across the TX group. And as I said, the focus of this talk is that I try to explain you some technical challenges and how we bring the decisions. There is a couple of things. First challenge was how we gather, how to gather this data, how we can collect data from all these different sources in different places. Then we had to deal with data quantity. It's a lot of data. So for instance, if you're in Ricardo, you deal only with your Ricardo data, but we had to deal, or if you're in 20 Minuten, you deal with 20 Minuten data. But we had to deal with Ricardo and 20 Minuten and Tutti and Homegate. So all the data that actually are important for those companies, we had to deal with them. So it's really, really a lot of data. When we solved it, okay, we said, okay, we are now able to receive all those data. Then we had to deal with normalization and the data quality of those data, how we can really use them, how we can normalize them, how we can be sure that these data have a good quality and they are true. Then we had to say, okay, how we provide now holistic data view, how this data can be really used by the company in some way. Doesn't matter if it comes from Tutti or Homegate, or it comes from Tagesanzeiger or TDG or whatever else. And of course, then how we can make this data exposed to the end users, actually to their IT teams that can reuse those data and make them useful for their products. First challenge is data gathering, and we are realized here that we started with the point, say, okay, we have anonymous users, and we have also identified users, so users who are registered, so that we know some data about them. Then we also said, okay, we have people who are using mobile phones and some devices, and also we have users with classical laptops or computers at their home. And also we have now some contents which are coming, let's say, article texts or videos or data like that are now in some other systems like Unity and so on. And then we decided, okay, we built something that we call Beagle Native. It's a SDK for iOS and Android that we actually deliver to all of those IT teams from engineering teams of those companies, so they can easily integrate it and provide us the data. Also, we have ultralight JavaScript library, which is called Beagle Web, that is running now on most of our TX Group portals. And also we provided specific APIs to be able to fetch and get data from these content repositories from CMSs or Unities and so on. So this was like a first step in our first challenge to do. Once when we solved that, we saw, okay, now we have some data coming, but then we realized that's really a lot of data. So we said, okay, let's now first focus on we created a very configurable and very scalable light application that we call Zuba, which is able to easily scale and easily integrate with build APIs, which will be kind of, I would say, stupid API that is not parsing message. Job is, okay, I just get message, I will pass it to Kafka, because we found Kafka will help us to really scale and handle this huge traffic that we have. Then easily we realized that we can those streams somehow create kind of channels. So we said, okay, we have user streams, event streams, content streams, and so on. So like we have kind of group of streams that are floating through our Kafka. Next. It's, as I said, this is now a challenge with a lot of data. I just have short here to show you. This is a kind of live how data comes to us. So it's a really, really huge amount of data. We have average like 5,000 messages per second that we need to handle to store somewhere. But we tuned our system to up to 20,000. And we had a really nice test last week, I think, when this Swiss government announced Corona. So systems survived easily without some big issues. All right, when we solved this, we said, okay, now we have a data entered into our system, so we have them. Then we had to normalize them and worry about the quality of data. Then we built something that we call internally Brutus. It's a set of apps that are able to connect to Kafka and do some easy transformation, data normalization, and filtering data and so on. This is all based on Scala and Akka. So we really use technologies that support huge amount of data, and they can really easily scale and do the things in the threads and kind of independently. So this really helped us a lot and speed up our development. At the end, we had to collect this data and to store those data to some storage that can be then easily queried and used for our products. First things that we started is something that we call the Zordon. It's also app written in Golang that is able to quickly, by configuration, connect to some topic and write this data to S3. Then we extended it using Apache Spark with also some batch processing of data, and also we use a lot Spark structural streaming, where we can connect, do live apps and some apps which are connecting to real-time statistics, counters, and so on. And also we have some other custom apps that are helping us to deliver this data. These apps are now storing all of them to some storage that we were really carefully looking into to satisfy our needs. So we use Amazon S3 for huge amount of data that we have. Like if you want to get some reports for last 6 months or last year or so on. So that's all in some gzip files on S3 that can be then easily processed with Spark and other technologies. Then like all archives for full text search and so on are in Elasticsearch. So all archives that you can see on our portals are served from Elasticsearch. Also, we have Postgres using a lot with articles, contents of data that help where you have titles, leads, and things that we show in our recommenders and products that we are building. Apache Hive is something that connects by Hadoop to S3 to provide a way of querying easily S3 data. There is also dgraph for identity graph where you connect the users between all these platforms. Like here we keep connections between users in a let's say to connect users from Tutti to 20 Minuten or Celeron users and so on. There is also Cassandra that we use for querying like real-time events like counters for clicks, shares, and other data. And of course, there is a possible to use different APIs to fetch this data. Now it's a way that we are working this holistic way, and we choose their Presto database, which is actually a cluster engine that is able now to connect to all of these sources and provide you like a uniform way to query all of them, even joining data between all of these different sources. So I would say most of these things is already available, already products are running of this, and we are really happy that we had the opportunity to develop something like this. And we are still have a lot of things to do, and we are working on this. But it's I would say majority of technical issues are there. Now we are focusing on a better exposition layer and better way to give possibility to users to reuse those data. Okay, that's more or less what I had to say in this short available time that I had, like 15 minutes. So if there is questions, I should try to answer if we have more time. I didn't follow strictly what is available. Yeah.
Thank you so much, Igor. Definitely super interesting. There were some questions from the chat. I'll maybe pick the first one from Martin. He was wondering how you evaluate the quality of the data and if you use a certain methodology for that.
Yeah, so we have, first of all, we have a dedicated person who is checking data quality. We call it our data quality specialist. And we were actually comparing data with Google Analytics and see what they see in their dashboards and what they have and what we have in our system. So I would say it was comparative way that we were checking that data are good quality and they're true.
Cool. Thanks. There were some more questions. Maybe you can answer in the chat because we'll have to move on to the next session. But thank you so much for joining, and the rest of you hope to see you in a few minutes for the next talk. Bye.
All right. Thank you. Cheers.